In this video, I will show how to solve a compound inequality in two variables. And the idea is that we are going to solve it in exactly the same way as we solve compound inequalities in one variable. That is, we are going to solve each inequality individually, and then we are going to perform the corresponding operation depending on the word that connects the two inequalities. And the rule is, if we have the word "and", then we'll be performing the intersection, and if the connecting word was "or", then we would be finding the union of the two solution sets. So let's go ahead and get started with the inequality on the left. So to solve this inequality, we are going first to graph the corresponding equation. So the graph of this equation is a circle centered at 1, -1 and radius 2. Since the inequality is non-strict, I'm going to graph it using a solid line. And since we have a greater or equal sign there, that means we are going to shade outside of this circle. So the solution of the inequality on the left is the region outside of this circle. Now, to solve the inequality on the right, I'm going to first graph this equation, and the equation is linear, so to graph it I can just use x and y intercepts. So when x is equal to 0, y is 1. When y is equal to 0, x is equal to 1/2. So we have 0, 1, 1/2, 0. So that's basically gives us the following line. Since the inequality is strict, I'm going to use dashed line to graph this inequality. And to decide which region to shade, I'm going to pick two test points. I can pick 0, 0 and test my inequality. So 2 times 0 plus 0 less than 1, that's true. And I can pick another test point, for example 1, 0. And at 1, 0, 2 times 1 plus 0 less than 1 is false. That means I have to shade the region that is the one that contains the origin, so to the left of the line or below the line. So I'm going to shade it using vertical lines. So this is the solution of the inequality on the right. And since we're solving the "and" inequality, that means I have to find now the intersection of these two regions. So, and the intersection is below the line and outside the circle. So the intersection of the two solution sets is the following. So it's below the line, but it is outside the circle. So this shaded region is the solution of the given compound inequality. So this is where both of them are true.